Okay, so we're going to examine this a little more. What is the gear ratio? Right, well, I need a gear ratio from A to B, and I need a gear ratio from C to D. Like the compound machines, I need to then multiply those two together to get my final gear ratio. Again, in out over in. All right, so my out is 40, my in is 10, so it's a gear ratio of 4 for A to B. Then I need my C to D. It goes from 20 to 50, so 50 divided by 20 is 2.5. Now I need to multiply those two together. So 2.5 times 4 equals 10. So my total gear ratio for this compound gear is 10. Okay, so drawing gears. It would be very difficult to draw gears if you had to draw all the teeth every time you wanted to design a gear system. For this reason, a gear can be represented by drawing two circles. You'll see me use that in some of the problems. Mine might not be perfect circles, but I get that done. A pulley system are used when there is a need to transmit rotary motion. The diagram below shows a simple system comprised of two pulley wheels and a belt. It is a simple mechanical device to winch up and down a rope. When the motor is turned on, it revolves the driver pulley wheel. The belt causes the driven pulley wheel to rotate as well, winding out the rope. All right, so pulley wheels are grooved so that the belt cannot slip off. Also, the belt is pulled tight between the two pulley wheels in tension. The friction caused by this means that when the driver rotates, the driven follows. We're looking at the same equations. All right, this diameter out over diameter in equals angular velocity in over angular velocity out, which equals torque out over torque in. Of course, we don't have teeth on this one, so we're not going to see number of teeth. But it's worked the exact same way. Okay, all of these equaling the gear ratio or pulley and belt system ratio would be 3. All right, sprocket and chain system. Everyone has seen a bicycle or used one and noticed that it is driven by a large driver gear wheel that pedals attached. Smaller gears at the back are given round. Smaller gears at the back are driven round, in turn driving round the back wheel. As the back wheel turns, the bicycle moves forward. Gears driven by the chains are used in machinery, motorcycles, car engines, and many more applications. And so a chain is made up of a series of links that the links held together with steel pins. This makes a chain a strong, long-lasting way of transmitting rotary motion from one gear wheel to another. Chain drive has one main advantage over a traditional gear train. Only 2 gear wheels and a chain are needed to transmit rotary motion over a distance. With a traditional gear train, many gears must be arranged, meshing with each other in order to transmit motion. Okay, again, equations are the same as the gear. We have the number of teeth on this one as well because we have teeth on the sprocket and chain system. All right, so again, our ratio is 2. All right, so let's compare them a little bit. A pulley has a belt, a sprocket has a chain. Right, the advantages of a pulley is it's quiet, no lubrication needed, it's inexpensive. A sprocket has no slip, it's a greater strength. It also is going to have a better torque because it gets into the chains and it's going to have a better torque than the pulley. The disadvantages, the pulley can slip. The sprockets cost a little bit more, they need lubrication, and they are noisy. Okay, I'm going to work problems in the problem videos, which you can watch next.